Ladies and gentlemen, welcome to the PacketBomb live stream experience! Happy to have you here today. Have some bad news. So let me just say, we were having a little bit of audio problems. Just trying to get everything set up where I can hear him and he can hear me and, all that good stuff, which the last two streams, the dress rehearsal has gone super smooth, and then we had audio problems in production in the live stream. We did figure out a workaround the first time, so it was no big deal. So I'm hoping with those problems that we had, that if you've ever been to the theater, it's like you hope for a bad dress rehearsal because that means you'll have a better opening night performance. Unfortunately, the telltale sign is that little transition that plays a little sound effect. If that is choppy, that's a sign that we're going to have audio problems, and I heard it being choppy just now. So I'm afraid when we bring in our guest, we're going to have the same problem. I don't want to spend a ton of time troubleshooting, to be honest, because we have a lot to talk about today. We did a live stream on Monday, live to the world, to test it, make sure it was fine, and guess what? Of course it was fine. I put everything the way I have it now for the most part, trying to reproduce the problem. So honestly, I don't know what the problem is. I can hear him fine coming in. All the audio and video come into a piece of software called OBS Studio, which encodes it and sends it up to YouTube. I can hear him fine. You can hear me fine. It's his audio and some background music that is choppy. We might do just a little bit of troubleshooting, assuming that we're going to see the problem again. All that said, okay. Stand by and we'll see. So anyway, this time next week, I will be frantically packing and moving. I have 1 week left in my tiny apartment in downtown San Francisco, moving out to a much bigger place west in the city where it's quiet and there's nature, still in San Francisco. So I'm very, very happy about that. I'm not happy about the next week. I took the next week off of work because I'm going to have to pack and do all that fun stuff that you have to do when you move. So I don't know when I'll be back online, when we might have another show. This is going to be it for the time being. Let me get my notes up. Notes. So yeah, that'll be fun. Oh, boy, Friday, guys. So what we're going to talk about today, I want to get to it pretty quickly. I don't have any crazy Blade Runner or Mars, skies to show you as last time. The air quality's actually been pretty good since then. I've actually been able to open my windows. It's been nice. I think the fires are getting contained, but it's still, it's a huge disaster. So that's been good. So a while back, on Twitter, if you know, I'm a big fan of the tcp-trace graph in Wireshark when I'm troubleshooting performance. I think the IO graph is a good tool. It's very flexible. I use it sometimes. Everyone uses a tool that they like and familiar with. I like the tcp-trace graph. I like what it shows me. I like the level of detail. It's not too much. It's not too little. Some people like Stevens graph. It only gives you a little bit of information, but it's what they like. I give Hansong, trouble all the time about being an old man using Stevens graph, but it's all in good fun. I mean, you use the tool that is useful for you. If you look at any of our videos, Wireshark setups, people have extremely minimal designs, just a few columns, no colors. They have a process that they've developed over time that they will highlight things they want to highlight. And some people have beautiful array of colors, everyone in the rainbow, all the time, and it works for them. And so when we see a tool like we're going to look at today that sort of just assaults your eyes, people get turned off. They're like, oh, no, that's not for me. That's way too much information. And I get it, because you have a process, you have a tool set. But, I think the things you hear about when you talk to people about Wireshark, when you first open it up and you see, especially with the default configuration, it's like, oh, it's just, whoa. It's so much to look at. Where do I look at? How do I get started? That's what we spend so much time talking about, process and orienting yourself, setting yourself up for success. All the work you put in prior to even looking at packets, and then setting up Wireshark in a way that makes sense to you and is not overwhelming. And then you can turn more things on as you get comfortable, right? So this is how I feel when I look at this tool that we're going to talk about today. You open it up and it's like, boom, 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 here's some graphs, and it's lots of things happening at once. right? So it's that beginner mindset again. All right, let's focus in on a couple things and figure it out. And we're going to talk about that today with this tool. So when I saw someone, I forgot how I came across it on Twitter a few years ago, someone posted some screenshots of graphs that were clearly tcp-trace like, but with a bunch of other cool information overlaid the top. That if you're looking at a throughput line over time, if you're looking at packet law, I mean, just tons of sort of like imagine IO graph and tcp-trace graphs superimposed on each other, where all the points are tied together, and you can get a clear picture if you understand what you're looking at. I was like, whoa, this is crazy. This is like wizard level tcp-trace. And the person who tweeted that, Phil Storey, has been on a couple of these live streams, and I happened to just mention that tool in passing because I couldn't even remember what it was called. And Phil's like, oh yeah, that NetData, I use that all the time. He was in the chat. We connected after that. He took me through the tool as he uses it. And I will say that there is what we're going to talk about today is the quote light version. It's free. It's available to you. I think previously it wasn't really posted anywhere. You kind of had to know someone who knew someone who probably would point you to Phil or someone else who happened to have a copy of it. So it is now available. It's in the description. There's tons of links about this and the work that Phil does in the description. There is a commercial version that costs a good chunk of change. I mean, we might talk about that, like what you get. But as you know, here on PacketBomb, I don't talk about any really paid for solutions that much. We talk about tools. If there's something that's useful that costs money, a lot of you guys work for big companies that have a budget. That's fine. I'm happy to talk about that. But I make it a point not to try to push anything, right? We're just talking about learning and the tools that help you do that. So we're going to focus on the light version today. I encourage you probably not to try to follow along so much, because really pay attention to what's going on. In the past, we've had tons of people in the chat when we talk about Wireshark and stuff who can hop in and answer questions. Maybe there's some folks in the chat who are real familiar with this tool who can help out. What I'm saying is feel free to post your questions. I'll try to keep an eye on the chat and I'll ask them to Phil as we go instead of saving them all for the end, because we're going to look at a few different things. Okay, I just rattled off a bunch of information. Why don't we bring Phil in? I expect there to be some audio problems. I'm sure you'll let me know. Or maybe I'll get my little headphone because I got my laptop running with the thing over here. Let me put it in. Ladies and gentlemen, please welcome to the show, Phil Storey. All right. Hey, Phil.
Hello.
All right, I'm going to check the audio as it comes through.
Oh, well,
yeah, it's the same problem. So I'm just going to go ahead and I think we'll just go ahead and work around it because I don't know what to do here to troubleshoot. We did all the troubleshooting before. I've reinstalled things. I've checked things. It's got to be, actually what I'm going to do real quick, I'm going to record a video because the encoder encodes it and saves it to disk and or sends it to YouTube. So why don't I make a video? And Phil, give us some audio.
Yeah, okay. Well, thanks for having me on. And I'm very pleased to talk. In fact, I could talk for several hours if you want.
Absolutely. Okay, I stopped the recording. Let's just go ahead and work around it. I'll check the video later. That'll be another data point for me. All right, folks, stand by. Okay, Phil, give us some audio. Again?
Okay. Yep. Thanks for being here. I've
yes.
got a wizard mode tcp-trace count.
All right, folks. Can we get some confirmation that the audio is okay now? Okay. Yep. All right. Sorry for the rough start there, Phil. I was hoping that we would get past that, but we're not. Thank you for coming on. I want to make it a point. Phil is in Sydney. I believe it is 3:17 a.m. in the morning in Sydney at this time. Did you stay up all the way through, or did you take a nap, or?
No, I went to bed early and got up. I actually got up about 1:30.
Okay, you went to bed early, got up at 1:30. That sounds like a rap song. All right, cool. So, yeah, this we're bringing you on to talk about this tool that my understanding is this is your primary tool. Like when you are a troubleshooting gun for hire. People have problems. They hire you to come in and solve the problems. Is this your main tool that you're using day in and day out?
Yes, yes, yes. And I have access to the Pro version. And in
Right.
fact, the Lite version does pretty much everything, but it's just limited to 50,000 packets.
Mm. Okay, got it. Got it. I mean, for our purposes today, we'll be able to do what we need to do, I think. I forgot to mention, sorry, just a quick thing. As I'm packing to move and I came across two more SharkFest shirts. So this one's from 2012. I think that brings my total up to just north of 10,000 SharkFest shirts. I couldn't find the 2010 one. You haven't made it to a SharkFest in the past, is that correct?
No, 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 I haven't. I'd love to go though. Well, just because I want to meet everybody.
Yeah, yeah. I mean, right. It's a in-person and online community, especially these days when we're had to go virtual with SharkFest. But I think it's a good point that there's so many folks, and I've met people via Twitter or via Reddit or whatever, who are really really knowledgeable and know a lot about this stuff, but who aren't necessarily at SharkFest or anything like that. So it is in no way a prerequisite to being a part of this community and contributing. So again, thank you for staying up till 3 a.m. Or well, it'll be well after 4, I'm sure, by the time we're done. But so give us a little bit of background as we do. Were you always in IT? Did you transition to that at some point? And then how did you get into this kind of packet performance stuff?
Oh, fair enough. Yeah, well, no, I was always in IT. I did computer science at university, at Sydney University. Got a job with American NCR, American Computer Company, back in the day. It was 20 years with them, and the role it was a pre-sales role, and I basically became the expert on whatever the new product they had. So they brought a commercial Unix box out in the beginning, and in fact, back then we used to connect these Unix boxes to SNA networks. There was no internet and TCP back then, and so I used to use a data scope, and basically got the hex on the screen, and you could tell when SNA traffic was working. So that was the first bit of that. But after that. Well, I actually used to teach TCP/IP classes for the company, and again, but in terms of what I knew about TCP/IP then versus now, it's chalk and cheese.
Sure, sure.
But I've always been into troubleshooting. I even bought a poker machine once because I wanted to know how it worked. So I want to know how things work. And,
A poker machine? You mean like as in cards?
not, the thing at the casino. You pull
Oh,
the
a slot
handle.
machine.
Slot machine. There you go. A mechanical one.
Yes,
Yeah.
yes. Got it.
Yeah, I must have been early 20s, or I was at uni, I think. And yeah, it was like $80 I saw in the Trading Post. It was a newspaper thing. Anyway, so yeah, career. I moved to a bank. I was in the infrastructure architecture team. I was a network architect, which means I used to draw pictures of networks and give them to other people and to happen,
Mm-hmm.
usually, but always troubleshooting. And what happened in 2009, we were going to move servers from Sydney to Melbourne. We were going to move out of a computer room in one building and move to Melbourne. And so we went out looking for who can analyze these applications for us, who can tell us which applications are going to work and which ones are going to give us trouble. Someone came along and they said, oh, 200 grand in a month, we can do it for you. But someone else had heard of this guy called Dr. Bob.
Dr. Bob.
His tool, and we got him in. And he came along and he said, well, I could do it. He goes, but I'd rather license you my software and train up one of your people and help you do it yourself.
Now, was
And
Bob a consultant as well? I mean, is this?
yeah, yes. So well, this is the thing. Yeah. So he is a full-time troubleshooter.
So he was basically eliminating future business by training up one of you guys.
Oh, well, because what happened? So I'm recalling Jasper's words from your video, that he said he'd never met anyone who was both a practitioner and a coder.
Yeah.
And so Bob is, and he's a mathematician, an engineer, and he's got a PhD in something, something to do with networking.
Right.
And so, and he wrote his own software. So 21 years ago, he started writing NetData, and he wrote it to use to help him do his work, troubleshoot things. And so what NetData is today is the summation of 21 years of experience.
Yeah.
And so whenever he found a problem, you can sort of see the checkbox in there. That he worked in a problem somewhere, and the answer was this particular thing, and so he made NetData find that thing.
Right. That it reminds me, what it makes me think of, because what he is an expert who built a tool to solve a problem and then added 20 years of knowledge and experiences bolted onto it, is what it comes across as. And it makes me think of this guy who used to have this old like antique store in my hometown, and he had it for decades, and so it was piled to the ceiling in tiny narrow rows, and there were undoubtedly untold treasures buried in there, but only he really knew where they were. And if he had to climb somewhere to get it, only he knew the correct path to climb up to the top and get it. So it was overwhelming, but it was, decades of experience of antiques and whatever, all packed into a tiny little place that, only he built himself. Maybe that doesn't translate, but that's what it makes me think of as, someone who's had 20 years of experience doing this stuff day in, day out, making a tool and just adding on. So it can be understandably overwhelming, but once you kind of start to unwind it and understand what it can do, then you really start to see the power of it.
Well, this is the thing. Yes, you have to know how to interpret the charts, which is really easy. It doesn't take that long. But yeah, at first you think, what is that? But the other thing too is, half of his coding work is about his slogan is visualizing IT performance, and so it's all about charts. But the charts also used not just so that we can find out what's going on, but we can print out the chart or email the chart or produce the report and explain to somebody else.
Right.
And I found even with me using it, if you sit down in front of someone with this chart and you go, now this thing here, that black thing, that means that this happened, and that blue thing, that means that that's happening. And so really what's happening is your server is running out of buffer space. And they might not understand the chart, but the fact that you're sitting there pointing at it and speaking as if you know what you're talking about,
right?
They go, right, let's get the server guy.
Yeah, and it does come across that this was built with a lot of forethought in mind of being able to report on the analysis. So being able to pin all the readouts and being able to document your work within the tool and take snapshots, which I think I've looked at your website and I encourage you guys to do. You've done a great job documenting some of your case studies and things that you've done. I remember there's one on there that about I think you suffer the same disease that some of us do, where we spend time spending hours of our life helping strangers on the internet that may not even care or ever come back to us and tell us that it was fixed or not. But you have one on Reddit on basically a performance problem where you use this tool to do some modeling, and you not only pointed out the problem, which many of us could have done with Wireshark. You went beyond that and were able to set up a modeling in this tool to pinpoint probably the exact router setting and what the value was set to. And they said, yep, that was it. And I was like, okay, this is another level that I personally don't have, I think, the skill set to. So I would encourage you all, spend some time on his website. Go look through some of the case studies. It's really amazing. So let's talk about our first case study. I think this goes back to what you were talking about when you were first introduced to Dr. Bob. He came on to train you to, how to use the tool. So tell us again what the situation was, and then if we need to switch over to look at some information, we can do that.
Yes, okay. So basically, we wanted to know which applications can be moved, which servers can we move without affecting anyone, and will any of these applications, cause some pain,
right?
Just by being. And so, with NetData, what we're able to do, so what would happen? I'd go in the morning, I'd sit with a person, and this is the person that does insurance phone calls, right? And I hooked up a hub and a laptop with Wireshark, and we'd just start capturing, and then we'd say, right, launch the app. And I'd write down launch insurance app, and 8 seconds.
Yeah.
And then we'd say, right, log in. And I'd wait until, wait till the second hand's on the 12 to do that. And then wait till the second hand's on the 30, on the 6 to log in.
Yeah.
And so we had the packets that related to each function. User function is what I call it in my document that you'll get. And then I could plot those transactions in those user functions, and NetData would count up all of the round trips. And then I was sitting next to Bob, and what we were doing was printing out these charts. We were looking at the charts to put in the report, and the count, the round trip count is in the top right corner. And on about the third day, I said, "Hey Bob, how come we're doing this? How come we're adding 15 milliseconds to that number ourselves with a calculator? Surely NetData should do that."
Yeah.
And so the next day he came back in, and yep, NetData has got it. Yeah.
Yeah, I think we've all been there. You're sitting next to a user, you're looking at your clock, okay, go, click. All right, now stop. Okay, let's wait till the second hand. Okay, go again. Or you've done some ping tool. All right, ping and then do it. I think we've all been there.
Yeah. So what I've got a PowerPoint that's got some of those charts from then on, because the trouble with like publicly available PCAPs is they're typically trace wrangled or something, and you haven't got the actual real transaction data, so you can't see that it's a SQL or a HTTP,
right,
or even a 3270. Bob wrote a decoder probably 20 years ago for 3270, and when you describe the transaction, you actually get a little map of the screen. So the screen looked like that, and the user pressed F12.
Oh, wow. Okay. So we're gonna have a look at this one. Really, just kind of look at the report and talk through the report, what these charts mean, and then we're gonna look at one of my case studies, my very first case study, which was websites were loading slowly, and we'll talk more about when we get there. Yeah. All right. Do you wanna?
All right. Well, I thought since we got here because of the wizard tcp-trace, I thought we'd start with that.
Okay. You want to, I guess, share, and we'll...
Oh, yes, I'll share my screen then.
Let's see.
There.
And you are there, so let me switch over. All right.
All right. Can you see it?
I can see it. I think everyone else can.
Okay. Well, I've tried to make it simple up front, and as simple as I could. But yeah, it's obviously a TCP-trace file. Here are the data packets. Something's happening at these little purpley areas. And down the bottom is the... Oh, well, here's the thing. So if you hover, you get a pop-up. And I'll lock one of those on. Oh, come on.
So just to be clear, I mean, this, if you're just looking at this, the line going up is... bytes over time, the normal, what we would, like a TCP trace graph, but we've got some extra information here.
Yes. And here's the other, so everything needs to be overlaid. Now, for some reason, the pop-ups are not. Isn't that
live demo?
It's annoying. Well, let me describe it, and maybe they'll come back as we zoom in or something. But what we've got down here is this is bytes in flight. At the bottom.
The bottom is bytes in flight. Okay.
Bottom is bytes. So this beige area is bytes in flight. This is obviously where we started. Purple things and numbers we'll get into, but we can see the congestion avoidance algorithm here isn't the usual Reno or whatever the normal one is. It looks a bit more cubic. It's got some curves in it, but we can see we get a lot of bytes in flight. We ramp up, and then something happens. And you see these little red ticks? So Bob put these there, I think, about 4 years ago. So there's packet losses happening up there.
Right.
And if you knew what was going on, you would be able to tell. But what this is doing is saying, right, packet loss occurred when we were at this many bytes in flight.
Okay.
Then we had we backed off, and we ramp up again, and we ramp up, and more packet losses. So we back off.
What is the sort of the checkered area that rises up and falls down?
Yeah, that's the bytes in flight that have been selective ACKed.
Okay. So that data was sent, but it was after the loss, so it's selective. Yeah. Okay.
Yeah. So when we zoom in here, the selective ACK stuff will make more sense.
Okay.
So this is the whole period. What have we got? this is 2 minutes. So the time this is the time at the bottom. So that's 240 to 242 in the bottom.
So
we've got 2 minutes.
is this the, I'm just going to read out some questions. Is this the standard view of this particular data flow graph, or have you customized this?
No, this is normal. This is just what you were going to get out of the box. Now, there's always a format control window at the top. Now, I don't want to spend too much time kind of explaining how to interpret NetData, but so because I knew I was coming on, and because it takes a lot of time to explain it, this week I've been busily making videos on my YouTube channel that basically step through how to interpret each chart and how to make these things go. So rather than explain it here, everyone go and have a look at the videos. And I've done a video for each chart. They turned out to be about 12 minutes each.
Yeah, so definitely, I believe his channel is linked below the video, so go check those videos out. And to the question on the Reddit post, it's on his website. If you go to his Network Detective website, I'm not sure exactly what it's under, if there's case studies or use cases or whatever it was, but there's one about Reddit. I think it was a PDF actually.
Yes, and I should say that modeling of queues is only in the Pro version. It's not in the Lite.
All right, thank you. Yeah, so, good to know.
That's right. So there's a format control window. I know it's over here, and these are all the things you can turn on and off.
So these are the different features that will overlay data that you can either turn them on to see it all, or if it's too much, you don't need it, you turn it off.
Turn it on. That's right.
Yeah, okay.
So I just turned on data throughput so that we can get this line.
Yeah, see, that's what I love about it, is that you either look at the IO graph, which shows the throughput, and have it drop, and you can put what I think Laura calls the golden graph, right? That shows TCP analysis flags or whatever. They'll come up when it drops, but having it overlaid on my favorite tool, tcp-trace, I think is really cool.
Yes, yeah. The stuff just jumps out at you. You can look at this and go, oh yeah, that's what's going on. Now my pop-ups have come back, and so we can see it's down here, and you can move this about this. So Alt Y does that, Alt X does that, and then Alt Z will lock it on. And so what we can tell here is that the beige area, we had 97 in flight, but there's a bunch of segments also that were missing. The reported is missing by the SACs. Anyway, so what we've got here is the throughput generally is about 1 meg. So it's a right-hand scale here.
Right.
So that's about 1 meg. Now I remember one time I said, "Hey Bob, you know what it would be good? It'd be good to be able to plot the throughput as the receiver got it, and you might be able to get that by doing calculations with the ACs that come back." And he went, "Oh, that's a good idea, Phil. Where would I put the tick for that?" And I said, "Oh, it'll probably be around here, wouldn't it?" And he went, "Oh, look at that. What's that?" Oh. So you can look at what the throughput is as seen at the receiving end, because this is the sender end and the throughput as seen by the receiver as we're calculating based on the ACs coming back.
This PCAP is a single PCAP, yes?
Yes, single PCAP.
And it's taken from the sender side or the receiver side?
The sender side. In fact, let me show you this. This is usually the first chart you look at, and clients on the left, servers on the right, and you can hover on there and get some data. We can see that there's a bunch of packet loss involved here. We got about 6% packet loss based on that color. And one of the options is show me the round trip times, and you get this nice kind of graph. So the vertical line, the client is close to the peak. The vertical line is where the capture was taken. So this is the client side one. If it was a server side one, the vertical line would be on the right, and if it was somewhere in the middle, it would be in the middle. It's very handy because you get to see every client server communication in the PCAP all in one go in one chart.
Okay.
So
this is taken at the client side, but the client is the one sending the data.
That's right. And
And
that's why that's beige. If it was the other way around, this would be green.
I'm, trying to wrap my head around, I certainly and talk about looking at PCAPs from the perspective of where it was taken. So if you have the client side, it's going to look different in the PCAP than the server side. And clearly the throughput might look different. But what this tool is doing is, one, giving you the throughput based on the PCAP, and then it's looking at the return data and estimating what the throughput looks like on the other end.
The other end, that's right.
Okay.
You can do that. Now I'll turn throughput off just to sort of try and keep the chart as neat as we can. Now what these black squares are now, so these little black things, we know they're packets along the normal tcp-trace type of graph. What these are now is representations, and again the right hand scale is trip times, or round trip times.
Round trip times.
So per packet round trip time. So the very first packet down here.
My head in the way.
No. Oh, right. I forgot.
I turned it off.
No. I'll do one in the middle. So Alt X, Alt Y, Alt Z. Okay. So the trip time. So this trip time here, it would be for this packet here, which is in the lossy area. So 829. The peak of these stacks of RTT measurements is at over 800. If I go back to this, the round trip time is 55 milliseconds, the normal round trip time. So what this graph, you can just look at that graph and go, oh right, there's queuing going on. So there's a downstream queue from us, and because packets are being queued, their apparent round trip time increases. So there's an 807. You can see that we get up to over 800. So there's 800 milliseconds of kind of additional round trip time being added.
Okay, so to be clear, like when I look at a TCP trace, the guidance I give is this is throughput, bytes over time. We want to see it going up and to the right. The steeper it goes, the higher the throughput. With that data, that is round trip time. So if it's going up, that means it's being queued. We actually want to see it more flat. That means we're getting consistent round trip time. If it's increasing over time, data is getting queued in a buffer. Is that a right read of this?
Yes, that's right. Well, that's the interpretation. It's being,
right.
The round trip times are increasing, and the normal way that would happen, or reason, would be that they're being queued.
Yeah.
And so I've zoomed into the left now, and here we see these trips. So the trip time, that trip time there for packet 176 is, so packet 176 will really be down here.
Right.
So the actual packet 176 is here somewhere. I'll just log that on anyway. So these are the packets, and these are sequence numbers on the left-hand scale. But these are just markers telling us what the round trip time was per packet.
So that's when how long it took the ACK to come back.
That's right.
Yeah. So we don't know if it's queued going out, if the data is going out was queued, or the ACK coming back was queued. Would that be?
Oh, that's a fair point. Yeah.
Okay.
That's true. Yep. But I'll zoom in a bit more. And in fact, let me turn off those trip times just because I'll try and keep the chart neat. All right, so this is like your more normal. So here's our data packets, and they're going to basically constant rate. Here's the ACK line coming back. So we can tell that the ACKs are coming back slower than the data was going out. It's a different slope. But here's the other interesting thing. This crosshatchy blue stuff is all about selective ACKs. And in fact, another option here, format, I'll turn on accumulate selective ACK, because a selective ACK can only have 4 left and right edges. And so when you've got lots of them,
it gets pretty messy.
Yes. So NetData is remembering that and plotting them.
Each of the 4, if there's up to 4 blocks, it will show you visually that there are, keep track of each one. And just to be clear, on this data, is this over a WAN? We know you said it's 55 milliseconds round trip time. What is the path?
Oh, yeah. This was, I think, this is an Ask Wireshark question. And this was a user uploading stuff to Dropbox, I believe.
Okay, which we put a link to this in the description. So this is the Wireshark Q&A link, right?
Yes.
And
Yep.
then you also put a link to the PCAP in there.
Yes, yeah. Well, the PCAP had gone from the Dropbox that was in there. I saw yesterday.
Yeah.
So I've made this PCAP available on my own website, networkdetective.com.au. But I've zoomed right in now, and we'll talk about what these selective acts mean. But here's another nice feature. So you see these red attachments basically to the data packets here.
Mm-hmm.
And there's now if a data packet's got a red thing attached to it, that means that we saw the data, but the other end didn't. And that's based on selective acts.
We saw the data, and the other, so that packet was lost.
That packet was lost after us.
Right.
So if we're at the receiving end, we'd see a gap there.
Right.
And then in that case, we'd see red and green packets. But yeah, so we can, just by looking at this, you can say, oh, there was a lot of loss there. But even looking at this selective act plot, we can tell. So basically, the selective acts are drawn in such a way that the light blue bit, and again, you hover on things. So this is the tip if you're using NetData. Just hover on everything and see what pops up.
Mm.
And so, and let me zoom in to that a bit more. I pressed a button up there to change the way the zooming works. And it's a bit more like that. All right. So what we can see is the crosshatched area. There was a selective act here that had left and right edge in there's the blue. So I got that. I didn't get this. I didn't get the crosshatch. I did get the blue. I did get the blue.
Okay.
I did get the right. So it's left, right, left, right, left, right in the data packets. And in fact, just let me take that opportunity then to go to this chart. This is a packet timing chart.
Whoa.
Let's not bother too much, but see a purple diamond is a selective act, a blue diamond is an act, and you see how the acts get bigger, and that's because the height on this area is a function of the size of the packet. So these selective acts, and again hovering something.
But
Anyway,
because the ACK is lifted away from the line, that means it's ACKing more data?
No, I mean, well, it means it's a bigger packet. So
Okay.
it's a selective act with 4 left to right.
Right.
And usually, if you hover on that, you'd see basically you see the 8 sequence, left, right, left, right. Anyway, let's go back. I'm very conscious about time. But so what we've got here, we got a selective act back, and here's our first retransmission.
Okay, that little line is okay.
So purple means retransmission. So there was a black version of this guy over to the left,
right?
And purple means it's a retransmission, and it's size 1440.
So I mean, just so we don't spend too much time digging in here. So clearly we have packet loss and selective acts, right?
Yes.
So what? Moving past, okay, is there anything about this that we would want to dig into to understand the problem, or just acknowledge, you know what, we've got packet loss, selective acts, we're gonna kind of look for the next thing?
No, you're dead right. That's it. Well, we've got packet loss, and we've got packet loss when we get bytes in flight to 100 there.
See, to me that is very, very interesting. You get, I mean, bytes in flight, and you also get the number of segments, which is the current congestion window.
Well, that's right. This stack here is the congestion window.
Yeah, I mean that's not something that is obviously in the packet header. It doesn't tell you what the sender's congestion window is. You have to estimate it based on the number of segments that were sent, in flight, and you can manually count it, I'm sure, but having it displayed to you right there is very cool.
Oh, very helpful. That's right. So yes, so essentially the beige area is the congestion window, and there's also these little counters that are on there, so that we can see it's 120 packets in flight there. And then the other thing, there's a little faint line there, which is the receive window, and what we can see is the receive window filled up here.
Oh, yep, sure did.
Yeah, so that's why we stopped transmitting. And so yeah, you're right. We spend a lot of time on this, but essentially, with this nice crosshatch blue, we can see that the sender he filled in all the crosshatch areas with these little retransmitted packets. So at this point here, everything's been retransmitted. But now here's the important thing: if I because we get that packet again there. So if I do an alt drag, then what we can have, and I can do an Alt Z and lock that on. In the top right, you see the 677.
Yeah.
So if I lock it, I'll do that. So you can also say, in this blue area. But anyway, this retransmission was 677 milliseconds after that one. So this is an RTO, retransmission timeout.
Yep.
So we retransmitted it. We retransmitted all those, and because the round trip time was up to 800 milliseconds by now, our 600 millisecond retransmission timeout went off before we got the ACK, because there's the ACK there.
Right. Right.
And Alt R gets rid of pop-up. So I just want to show you.
So what you're saying is the ACK, okay, so because of the queuing, queuing is so impacting the performance so much that the retransmission timer expired, the data wasn't necessarily lost.
That's correct. And in fact, I want to show you that too. So yeah, because here's the ACK line stepping up here after the retransmission. And I just want to show you this other thing. Because I did an Alt drag, we get this green line now, and that's resetting the delta time, if you want to put it that way.
Yeah.
So now when I hover on that, I get this 0, and when I hover on that one, I get the 677. So as I hover on things, you'll get the time in there. So these are all unnecessary retransmissions. So if I right-click at the right, we'll get another indication. We got these things. And what are these? These are DSACs.
Yeah.
And if I go back to this view, DSACs on this chart are green diamonds. And, and there's the left and right edges of that. So so DSACs, for anyone listening who doesn't know, it's using the selective ACK mechanism to tell the sender that he sent the same data twice.
Right.
So it's using selective ACKs to say you sent duplicate data. And you see all of these, we got them all. And also you can see the slope. The slope is less slope there.
Right, right.
ACKs came back slower.
I'm trying to imagine looking at this in Wireshark, and I think right away people who were pretty decent with Wireshark are going to say, oh, we filled the receive window. And Wireshark is really good about calling something like that out, kind of putting it right in front of your face with expert infos. I'm not sure if this tool doesn't do much of calling things out. It's just up to you to spot them. But this certainly makes it easy to see that the problem really isn't that. It's this queuing problem.
Yes, that's right. And I just wanted to show you something else. I'll just zoom into, right. I'll go back to normal mode. I just wanted to point the subtle little things all the way through NetData. You see these little numbers, 1, 2, 3, 4, 5, little purple numbers on the bottom there.
Yeah.
This is the ACK line, and so these are the count of duplicate ACKs, and SACs are treated as duplicate ACKs, and even the color. So 1, 2, the third one goes purple because the third duplicate ACK would have triggered a retransmission.
So every bit of information, there's already 100 bits of information, and then each of those bits of information can be color coded to give you more information about it. So this is a high bandwidth tool for your brain.
Yes, but it's doing a lot of the work for you. So you can focus on the high level things. If you click on the right here, so we basically got to the bottom of this. It's we're filling up a buffer downstream from us, possibly the guy's home router even. And because of that, we're getting a packet loss, mass packet loss there. Our congestion window is dropping right down. We're ramping back up again, and when we ramp up to 100K again, we get more.
Right.
What is interesting though is that the packet loss here is different than it was at the beginning. There's less packet loss because remember the crosshatch areas, and as you go to the right, you'll see that continues. So the first lot of packets was really bad. It's not quite so bad early, but it's still enough. If we hover here, we were up to 100K or even 135K in flight there, and we backed right off down here to 12 seconds. So we went from 69 to 12, but then we ramped up relatively quickly.
Right. So this is, I mean, we would think maybe just classic buffer bloat.
Yeah.
In a home, in a network, a home internet situation, which we've talked about on the stream, we've talked about, I think, in different sessions, maybe not on here, but certainly I've heard it at SharkFest, where, your buffer bloat gives TCP the illusion that it has more headroom than it does, and then when it all comes crashing down, it can significantly affect performance as it has to recover.
Yes. Now the nice thing here, this is a modern TCP stack, because it's the throughput. Although we get these the throughput comes back to normal quite quickly.
Yeah, it ramped up quite quickly there.
Yes. So it looks cubic or something like that. It's not the our traditional sawtooth. Yeah, if it was the old congestion avoidance algorithm, this would be these sawtooths at the bottom. There's lots of charts of that. But yeah, it's just that there's all this stuff that you can.
Is this graph the data flow trip times? This is in the light version?
I'm using light now. Yep.
Okay, yeah, he's using light. So I would say, did you do a video on this graph yet?
No, it's coming up.
Okay.
I thought I'd save it until after this.
Yeah, no, fair enough. So just real quick, show us from the main menu how you get here.
Yeah, okay. Good.
And then after that, let's go ahead, just in the interest of time, we'll go over to the proxy one.
Yeah. Well, I'll tell you what. No. So when you put the NetData icon on the desktop, there's a no slow start. I just dropped that on there, and then NetData, it took about 30 or 40 seconds. It did its thing, built the database, and you'll get this window. And then what you have is these big buttons. They're kind of the order at which you do things. So the first thing you usually want to look at is the dialogues, and I already had that, didn't I? And so typically you want to know the
right. So we're talking about, in the same way that we harp on a consistent process and approach with Wireshark of, I open a PCAP, I'm going to go to statistics conversations is my first step, and this is kind of that. Let me go look at the dialogues and see what's in this file.
That's right. And then the next thing is performance, and the performance is all about transactions. And in this case, there's not really transactions in there. Well, actually there are. So these things, it's SSL. So NetData's kind of made transactions, and that's a 12-second transaction. But on, just interesting while we're here, packet losses happened at this time, and so we can see what effect packet losses had on the transactions. But we'll skip
that for now. Yeah.
Rather than timing and data flow, you could push this button here, and you go straight to that chart that we had.
Okay, so the data flow button. Okay, so to wrap up, or to start heading that way, we'll certainly go over today. That's fine, because I think this is very, very interesting stuff. My very first case study I did, someone reached out to me via email. He was, just an IT guy that gets contracted to help local businesses, and they were having a problem at one customer where all the websites were, seemingly, I think pretty much all of them, were opening really slowly. Long delays. It would wait, and then boom, it would open the website. I had him get a PCAP. I went through the case study. We solved it. And we'll go ahead and say, it's already out there. No spoilers here, but because we want to understand how to get there. They had a proxy, like a security proxy, that a previous person installed. They hadn't forgotten about. And when they changed DNS settings in the environment, no one changed the DNS server on this proxy, so it was taking DNS timeouts. And we went through in the Wireshark way to determine how we arrived at that conclusion. So we're going to do the same thing with NetData.
Yeah. So while you were talking, I simply grabbed that PCAP and dropped it on. And while you were talking, you saw all these things pop up. It was doing all its building database and everything. And then it's decided, rather than, this is a slightly bigger, more complex PCAP file. So rather than pop up all those charts that you mentioned before, it's giving us an option. What do you want to do? You could tick these boxes and get them all, but we will just look at the dialog chart first, which is the normal sort of thing we would do. So here, there's one client, so we tell straight away, there's one client and there's lots of servers, and it's all HTTP port 80 in there.
Yeah.
So if there were different protocols, they'd appear. If there was DNS in here, NetData would have put the proper name. So because there's no name, it just makes up this thing in parentheses based on the MAC address.
Right. And the manufacturer of the MAC address.
The packets that we saw coming to us from what we think is that server had that MAC address.
Right.
Right. Yeah.
Which normally it would be your local default gateway on a normal network, right?
Yes, that's right. So the first thing that jumps out, we're looking at retransmission rates, and so blue is 0.006. So the others are black. So there's not many. It's not really a network problem we're looking for. And again, I say hover on everything, and if we hover on that, and I'll Alt-Z it, then we can see that there were 4 connections, 5 transactions. Setup time was 0.17 milliseconds. So
that's the handshake, right?
Yeah. So here's where we see, oh, that was fast. What about this other one down here? Oh, well, that was fast too. And what about that one? Oh yeah, they're all pretty small. So
which is a huge tip-off. If you're talking to a bunch of random internet websites, they all have sub-millisecond response times on the handshake.
That's right. Now, if I hover on the IP address itself, there's another clue, and so it's slightly different because I'm on the node. Then we're getting this, and what we see, MAC address. There was one MAC address going out, and a different MAC address coming back in. So there's 2 different MAC addresses.
I mean, but that's the PC's MAC address is a sender, and the what we assume is the local gateway is the response. Is that what you're saying?
No, I'm not. So here, if I hover on the PC itself, that's the PC MAC address, Dell.
Yeah.
This is saying that we observed this MAC address for packets that were going out from us, and we observed this MAC address for packets that were coming back in to us.
Huh.
So there's another clue there that on the local network, at least, the packets are going in different directions. They're going one way and come back another.
Okay.
So what we would do, options again, show me the round trip times, clients and servers, and here is a round trip time. So we can see that it's a client side capture because the vertical line's on the left.
Right.
And all of the trip times for these guys are all under half a millisecond. So they're all tiny.
Right. And here we're just talking about TCP.
This is, the TCP connection time.
Right.
That's right. Yeah. But there are these couple of outliers. So in fact, there's 2 things drawn. The green line is the legend down here, is the connection setup time. And the purple or black is the packet round trip time for data. So the data the data round trip time was much faster than the initial setup time. So in this case, I don't think it matters much. It's just some kind of artifact. But in some cases, that might really matter. So 2 different colors. So setup time, and in fact, it's in the pop-up. The minimum round trip time for data ACK was 0.7, but the connection setup in here was 3 milliseconds for some reason. So the bottom line is, there's some local transparent proxy. It's transparent because we think we're talking to the real servers. If it was a non-transparent proxy, we'd only see one server, which would be the proxy.
Right.
So the next thing we typically would do, and you can right-click and chart records of just that server, but I'm just going to press the performance button and say give me everything. So this is where NetData becomes really powerful, because here we're not plotting packets here.
Now it's
These are,
application turns, right?
that's right. So these
Yeah.
are transactions, and again, color, shape, position, all matters. So if I hover on a thing, then that was a post, but it was terminated by the client. It was a 433 byte request, a 75 byte response to that server, and the server spent 12 seconds thinking about the answer. So it's 12 seconds of SRT in Wireshark words. And so in this chart, the height, so because this is a 12-second transaction, it's at the 12-second height on this left-hand scale, and that's when it started, and that's when it ended. And because the symbol is at the right-hand end, we know that was all server time in there. If the symbol was somewhere not at the right-hand end, then symbol to the end would be the data transfer time.
Right, right. So if it was
And again,
a large response, because that dot represents the headers, which is the beginning of the server response, it might be in the middle, and then there might be several megabytes of trailing data, and that's what the line would represent.
yes, that's right. So when you see the line, but essentially from what we're looking at now, they all seem to be server time.
Yeah.
I can click this trans button here, and I'll get a spreadsheet essentially of all of the transactions. And so there they all are, and there's a length of response, length request. There's on all NetData tables, there's the columns button, columns, and you can turn on and turn off all of the columns.
Wow. Yeah.
That you're interested in, and you can sort by things. So what was the largest response? So 2 clicks. Purple means that it's sorted descending. I'll scroll to the top. So the biggest transaction in there was this 1.1 meg transaction, and I can right click on that, describe transaction. Where to go? And usually, there it is, and you'll get this window with the transaction data in it, and it's all nicely formatted for you.
Oh,
But
yeah.
in this case, it's the header is this. There's the HTTP fields, and it was an image, wasn't it? Oh no, it's a oh, hang on, what are we doing? Oh yeah, it's a get. It's a get.
Yeah.
Oh, get. Yeah, it's not an image. So yeah, it's whatever that blob thing was. It was
Right.
that's. We can also see that there were 3 of those guys, or at least 2 the same anyway. So that led me to think that this was generated by some kind of load balancer. Oh, well, let's say this one. Right click on this one, describe transaction, and we'll get it's an image. Where is it? Oh yeah, it's a JPEG.
JPEG, yeah.
Yeah.
So here's a question from the chat. I mean, all this is fantastic, but it requires seeing the protocol.
Correct.
Does the tool have the ability, if we have a key, to decrypt SSL, or how do you handle SSL?
Oh well, if SSL, you'd see the SSL still as these transactions, but you don't know what's inside. But they still
Right.
appear, given the SSL request and response, they still appear like this. So you can see, the how big they were, whether it was server time or not. But yeah, you can't get the content.
Okay.
But funnily enough, just a couple of weeks ago, we talked to Bob about this, because what we discussed really was, do we want NetData to be able to do that, or if we're in that position and we do have the keys, do we or can we get Wireshark to do that
and
then
save it?
Get it? Yeah.
Yeah. I mean, yeah, you still get valuable information on transaction times. You're just not able to go into the application protocol level. If the problem lies at the application protocol, you won't have that visibility. If you could decrypt it like with a key or session key, you could do it in Wireshark, save it as unencrypted, and then bring it into here. It sounds like.
Yeah, that's right. So yes, NetData doesn't do that job. So there are a few things that that Wireshark can do that NetData doesn't. Pulling out the voice, for instance, in a VoIP call. but I just wanted to
Right,
come here. Remember we looked at the Ariana Grande JPEG?
right. We did?
Yeah. So the act of doing right-click describe transaction when it's an image
Oh, it saves it out.
extracts the image into your NetData Lite
Okay.
directory where you're.
Okay. Well, I'm glad you chose that and there was nothing else in there that was more shocking. But yeah, so this, as you mentioned, this is a tool that one person has been writing for 20 years. It only runs on Windows. So, as a number of applications are like that, that's, you got to run it on Windows.
Yes, but here's the thing. When I watched your video obviously before I did this. You found a couple of transactions that were several seconds, and you did your secret little trick to make delta times stick to be in the with a per transaction. Whereas here, when this pops up, we can see that well, some of the questions we might have would be, are these transactions long for all servers or just one?
Right.
And we can see here, here's a legend of servers. All the servers are different colors, and all of these are different colors. So it's affecting everybody.
A wide array of stuff there. Okay.
Yeah, that's right.
All right.
So,
do you want anything else you want to say about this one to bring it home?
Oh, there is, statistics. Again, and so here we're getting per server statistics. If I double click that, and we can get the statistics about there were the transactions, which had the most purple. Right, so there was three of those, two of those, and the statistics can give you a lot of information. While we're on this chart, I will do this format. Concurrent connections are on at the moment, and there's really not much to see, but you can have throughput, which is arrival rate. So this is the arrival rate per server. So the arrival rate line is different colors for representing each server. And again, that's what made me think it might be a load generator, because it's kind of ramping up.
Yeah.
And then the other thing, well, in fact, I'll use this capture to jump into the next topic. Turn throughput off. Throughput can pay off when, because essentially, if you see, not throughput, sorry, transactions in progress. So let me do that. Transactions in progress is how many transactions are occurring in parallel. It's essentially, if you draw a vertical line through, how many horizontal lines do you intercept? And we can see that there's always only 6 transactions in progress generally per server. And that could indicate that there's some kind of thread limit of 6 somewhere.
I mean, is that across 6 TCP connections, or?
Yeah, well, let me turn on TCP connections as well. And yeah, in fact, you're right. In this case, there's only 6 TCP connections are created per server.
Right, which is generally a function of the browser.
Yeah. Yes, that's right.
Yeah.
And in fact, so in that case, the limit of transactions in progress is that. It's
right.
Nothing to do.
How many TCP connections, when you say www.whatever.com and it goes blah, and Chrome is going to do X number of connections to that server right off the bat, just so it has a connection pool set up ready to go to do concurrent connections to increase performance. And this is a way for you to, I guess, visualize that.
Yeah, and in fact, I found one time in a paid job where that connection limit of 6 or 4 applied when you were talking to a proxy, and so you could only have 6 concurrent proxy connections, even though you were talking to 60 different servers. So when they disabled the proxy, the application worked great because it could do 50 connections to 10 servers. When you turned the proxy on, you were funneling all your transactions through.
Yeah, that's a problem.
Now, we mentioned before, you see this little pink square around this one?
Mm-hmm.
Pink square means there was some kind of network abnormality behind there. So a usual thing now would be we would right-click, plot packets. I'll clear out any if we already had them, and then we start to look at packets, and so we get the packet timing chart, right? So this was one where there was a lot of data being returned, and there was that yellow server time at the beginning, and then we got 193K in 800 milliseconds, which were these packets here. So these are client packets, server packets.
So there's, I mean, you just pointed out, on the previous one, there's a dot that means something. It has a color that means something. And now there's a box around it that means something. Is generally everything to interpret all these graphs? I mean, there's lots of options you can overlay, lots of data. In general, is everything in a legend? I mean, I'm looking up above. I see, I see the legend. It's got the box. Is that enough?
Yes.
Is there additional documentation that helps people understand and interpret what all the different little things mean?
You mean documentation in here, like
or maybe written documentation outside the tool? I mean, the legend will tell you. Okay.
Yeah. In fact, if your viewers are going to download the zip file for NetData Lite that I've put on my website, there's a bunch of docs in there. In fact, let's worth talking about that. So, in I made a zip file, and it's Dropbox. I'm using Dropbox here, but all of this is in the zip file. So there's the runtime, the executable, and then I put this docs directory. And there's some documents, and I even put them in audio. I think you should read them. But there is a charting guide. There's essentially that's the documentation.
Okay, no, great, fantastic. And this, to be clear, this is not an installer. This is a standalone application. You get an executable with some supporting DLLs. You can drop in a zip drive or wherever you want. When updates come out, you're generally just overwriting the exe or DLL, and that's it. Simple.
Yes. You keep all the DLLs and everything, and you just plonk the new executable in there, and that's how you get your upgrade. But speaking of this is a function that's only about 2 or 3 weeks old, and if you hover on the legend here, and I can lock that on even, then it goes this yellow, and so that's that guy. So when you want to know, where are these gets? Hang on, I've got to go. Where's that get? Then there it is there. But we're also getting, we're also getting to see that this is one. It was that long. It was this much server time and that much data transfer time.
Yeah. Okay.
Now, what I wanted to do, I'll leave that there. I just wanted to run through the PowerPoint. Oh, I had this ready to go, and again, this is in that docs directory. It's how to interpret these things, right? And green, yellow, that, and so yeah, have a look at that. And what I'll do, jump to this. So this is another. I wrote this just a few weeks ago, and it's all about how can you essentially it's documenting what I did back then. And so I'll quickly run through this, and then we'll do a live one. It's doing that. So you'll have this, so you can read it.
This is linked in the description. This particular report.
Yeah.
Okay.
Yes. Yeah.
Okay. Well, let's just do a quick overview. Now, as we are running a little tight on time, we'll do a quick overview. If folks, want to download it and look at it, and then we'll talk about how to get in touch with you.
Yes, that's right. I'll let you read it. And please get in touch, because I love to talk to anybody. But this is what we call a waterfall chart, and so these are the individual transactions that were involved in whatever this function was. So this is like insert new insurance or something, and it's SQL. So these are the TCP. I've whited out the IP addresses and things, but this is with the protocol. Pretty simple. there was a connect, and they basically just followed on after each other. So in this function, this whole user function, we've got this table at the top. So there were 24 round trips, and basically we said if we made the round trip time 15 milliseconds instead of whatever it was, our quarter second thing would turn into a half second thing. So that one passed the test. And this one, another one. This one was 0.17 of a second. It would become nearly 1 second. But this one was a 32-second job to begin with, and this might have been something like, launch app. But if we move that server 15 milliseconds away, it would become a 6 minute.
So to be clear, what we're talking about here is, this is the thing you talked about at the top of the show. We're moving an application to a different location. So what is the impact? Here's how it runs today. Let's baseline it. What are all the different transactions it's doing? If we move it and change the network characteristics for the clients by whatever, add latency, whatever we're doing, what is going to be the impact? So this is application migration. Today, you might be doing lift and shift to the cloud. You might be moving it to a different data center. Maybe you're refactoring it, whatever it is. I mean, this is something that's been going on for more than a decade and is still going on today. So this kind of approach and analysis, I mean, businesses absolutely need to do to understand the impact on their applications if they're moving them.
Yes, that's right. And in this case, well, not only will that be the impact, but why? And why is because it does 20,700 fetch continuation one row from a database. So
right.
it does a select statement, gets one row, and then says, give me the next row, give me the next row. So this looks like a solid blue rectangle, but it's actually 20,781 of these.
Yeah. Stack those up and it's quite a lot.
Yeah. And so that's where you could say, hey, and I went to talk to the guy who developed this, and I said, how come you're retrieving only one row at a time? He went, I just call an API. So, and this is the thing, this was something I want to talk about, was decisions made by vendors that can cause enormous performance problems, and you don't even know because the vendor made a decision. And in this, and Oracle one is really common because they will only retrieve, the Oracle JDBC driver has got a 10 coded into it, so it will only receive 10 rows at a time.
Yeah.
So if you do a select statement that returns 20,000 rows, you get them 10 at a time, and you don't know.
And this is all, this is all abstracted away from the developer. The only way to see it really or know about it, I guess, is on the network. I mean,
yeah, well, I think so.
I don't know.
And then plot it like this. So here's 132 fetch 100. So this is doing 100 at a time. But yeah, this was quite useful. And what I've done is, again, just look at that. Now this is coming from your PCAP that we've got going now. And I just picked a place and plotted it and turned these on. So let's do that live. And for your readers or viewers, I added this slide of how to do it, how to produce a waterfall chart.
Okay.
So let's get out of that and do it.
All right, we got about, I would say, just a couple more minutes. I want to leave some time for any questions. So we'll go through this, and then we'll figure out how folks can follow up.
I'll be really quick.
Yeah.
This is a whole bunch of packet time, a whole bunch of TCP connections and client server packets. But you press the waterfall button, you get something like that. And you can see that there's a lot of yellow time, server time, a lot of blue time.
Right. So pretty familiar if you look at like developer tools and like web route, HTTP Watch, I think, or Fiddler, or the Chrome developer tools, something similar to that. Yeah.
That sort of thing. And what you can do in here, I did format. There's effect of alternate loop delay, and if I put in there, and you can put an alternate loop delay per server. But we'll just put it here and say, righto, let's make everything 50 milliseconds further away.
So you can do modeling.
Yeah, and that's what this is up here. So that red bit is the extra penalty.
Oh, very cool. What about, someone asked about packet loss. Can you model different network conditions as well?
Um, oh well, the modeling. The modeling isn't in the light version, but
Okay.
it's queue modeling. So the modeling that's in there in that Reddit post is all about modeling the behavior of downstream queues.
Okay.
So
Okay.
you know, what rate? So it models. We're sending data into the queue at 10 megs, and it's going out the other side at 1 meg. Then we can calculate what the queue would be, and then we can tell when the packet losses occurred that it looks like it's got a buffer of 100K.
Right. Okay. So not necessarily packet loss, but and that's in the full version. Well, folks, I do unfortunately have a hard stop coming up. I think this is, I mean, folks, you can clearly see we're scratching the surface about what this tool can do. I would highly encourage you, if you find this interesting, then I would, here, I'll put it back on guest chat. I would download the links, check them out in the links. Certainly, Phil has been putting out some new videos to go through some of the basics that we didn't necessarily want to spend a lot of time on here, but as you can see, there's tons more that can be talked about. So either Phil will have to, do more videos, have his own show, or we'll have him back on in the future. But I want to give a second for Phil. You can, if you have some parting thoughts, while folks, if you have any questions, please drop them in the chat here as we wrap up.
No. All right. No, I just encourage you, download the thing, install it, play with it. I do have to say, the free version thing, this is Bob's living. And so the free version is still in a sort of a delicate phase. The normal free version, it's 50,000 packets to begin with, but then it drops down to 5,000 packets. And initially he made it a month. But for this, for the one you're going to get, it's going to stay in 50,000 packet mode until January.
Okay.
Then it will go. Then it will drop to 5,000, and it'll work at 5,000 forever. But in the meantime, it's a changing thing.
Clearly, I mean, there's a unique relationship you have there with Bob, and I think you have this light version as a customized for you that you're giving out. So thank you for being willing to share it with us. Certainly, people can filter their PCAPs down and hopefully be able to use it. I just wanted to highlight that I think I was impressed by what I saw. And the fact that there's at least some kind of free version that people can play with no cost to them. I wanted to make sure that people had that opportunity to do that.
Well, that's right. And and I should stress, yes, it's not my software.
Yep.
I'm a user.
Yeah.
But I do know Bob very well. He only lives 5 miles away, and got to know him over the 11 years of using it.
Yeah. No, that's very cool. That's very cool. All right. Well, how should people, as they go through this, they have questions, they want to reach out to you? What's the best way to do that?
Well, email. I think my email's address in that there's a hints and tips, so definitely read that in that docs folder, and I think it's got my contact details. They're in there somewhere. It's certainly in my videos. But yeah, I suppose email or Twitter. Email.
Sure. Okay. Yeah. That I think most of that.
And I'm really happy to talk to anybody.
Yeah, absolutely. All right. Well, folks, thank you so much for joining. Phil, thank you for staying up all night and sharing your knowledge with us. I think this is very cool. I hope people get a lot of use out of it. Give it some time. Start simple. It's easy to get overwhelmed, just like it is with Wireshark. So this is something new, but I think there's a lot of potential value there. So, folks, again, thanks for joining. I'll let you know when I'm going to be moving. So I don't know when I'll be back online, but we'll figure something out, and we'll see you next time. Bye.
Good luck.